or make sure that you have some source where you can get more from. And the more you do on these kind of problems, you'll get used to it. Okay, so all of these problems are very, very similar, but make sure that you can do all kinds of work problems on your loaded rates. Okay, so let's look at example 5. A ladder of 10 feet is leaning against the wall. If the bottom of the ladder is moving away from the wall at the rate of 3 feet per minute, how fast is the top of the ladder moving when the top of the ladder is 6 feet from the bottom? And so here's the vertical wall and a horizontal ground, and I do a 10 feet ladder here. So this is 10 feet, so let me just write down the units here, 10 feet. So that's a 10 feet ladder. And as the bottom of the ladder is pushed this way to the right, what happens here is as this point right here is moving this way at a certain rate, what happens? This point right here is actually going to come down.
I'll meet you back here.
It's going to come down.
After work, because I'll make
Because the
stuff
ladder will always be against the wall. If the ladder is not going to flip up to the other side, but the top of the ladder will always be on the wall, against the wall. So now the question is about this point here on the bottom, and the question is about the top point right here. So it looks like we need the variable. So we can create a point like this and call this guy x, 0 like this. And then assume that we have a built-in axis over here, x-axis, and y-axis like this. And we can do that. And then this point, we can call this point 0, y. And we can create variables here. But what I like to do is, I'm not going to create these point variables. What I'll do is, we'll just create distance variables. Again, we have point variables, or we can create distance variables. The distance variables are a little bit easier to understand. So what I will do is, I'm not going to call this the y-axis, nor the x-axis, and I'm not going to call this x, 0, and this is 0, y. What will do is, I'm just going to create a distance variable, and this one I'm going to call this guy x. So instead of creating a variable for this point, I'm going to create a variable for this distance. Because the distances and the points are kind of related. And this origin is the fixed point here. So you are going to use this point. So I'm going to create a distance variable rather than a point variable. And then since the top, the question about the top here, I'm going to let this distance be y. Again, I'm creating a distance variable, which is a little bit, I think, easier to understand. Okay, so now what? So these are the two variables we need. Y from the question. Y, what is the question? The question is, how fast the top of the ladder is coming in? How fast the top of the ladder is moving? Then we need to know how fast this point is moving. In other words, how fast is this y changing? That's what it is. And then the question is, the ladder, the bottom of the ladder is moving at 3 feet per minute. The bottom of the ladder is moving. That means this point is not moving. That means we can now get a variable x here. So I have created, instead of point variables, I created the distance variables. So now, what is the question? The question is about the relationship between x and y and 10. So what is the easy relationship between x and y and 10? That's not too hard. In this case, there was only one setup really. Setup. The setup standard. This is what I call the standard setup. Okay. If you want to do time setup, you can try that too on your own. Okay. Anyway, I'm just going to the standard setup. The standard setup is what? Maybe I should not even call it standard here. It's called a setup. Okay. All right. The setup. What is this? This is going to be x squared plus y squared is equal to 100. So this is the equation which relates x and y. Now, what is the condition? The condition says that the bottom of the ladder is moving away at the wall at the rate of 3 feet per minute. If this point is moving, the bottom point is moving away at the rate of 3 feet per minute, that means x is actually increasing. So what we have is dx dt is equal to 3 feet per minute. 3 feet per minute. And then the note that the original equation has two variables, x and y, with no t. So one condition is good. And now what is the last question? The last question, I want you to write it down. Question is how fast the top of the ladder moving? That means how fast is the y changing? Basically, that's what it is. So now let me write it. So that will be what? That will be find what? Find. So find what? Find dy dt. Find dy dt. How fast is the top point moving? Same as the question, how fast is the distance y changing? The point information is converted to a distance question. Find yt when what? When what? When the top of the ladder is 6 feet. Y to 6 feet. By the way, this implies the part of the time condition is this. The part of the condition is, now this one here, let me write this in yellow, maybe light green, and not this one in light green. This one here, I'm going to write this in light green, and the light green is going to be this. Light green, when x equals y, when y equals 6, x is equal to 8 feet. So I'm going to put that in light green, okay? So the time condition is actually up to here. The setup is actually up to here, but we include that x equals 8 as part of the time condition. We need that. Again, if you do not include that x equals 8 in the time condition, that's okay, but eventually we will need this guy. So I wrote that in light green, okay? It will be part of the time condition. And y equals 6, x will be 8. Okay, so now let's solve this. How do we solve this here? Let's solve this. We go back to green. What do we get? Now we take the derivative both sides to t. So what we do get is we get dx dt. So we get the 2x dx dt. Then plus 2y dy dt. Equals 0. Now multiply both by half, so that the 2's are all gone now. And then once the 2's are gone, then what we just have is this. We have this. Then we have this. The plus, we have this. Y, and then times dy dt equal to 0. All you have to fill it in. So 2's are all gone now. You can multiply both sides by 2, so 2's are all gone, and now we fill it in. What's this? dx dt is 3. So dx dt is what? dx dt is 3, so dx dt is 3. And then what's dy dt? Well, that's what you're looking for. So dy dt is, positive dy dt. So that is the question. And then x and y, you have the time condition. Then y equals 6. Y equals 6 is right here. And then x must be 8. So you can see here, what is dx dy? What is dy dt? Dy dt is minus 24 divided by 6, and that will be minus 4. Minus 4, what is the unit here? The unit will be feet per minute. Feet per minute. And do we expect the y to be a negative number? dy dt to be a negative number? Yes. Because that point is actually going to be, the top of the ladder is actually going to come down. As that point comes down, the distance y is actually going to shrink. Therefore, dy dt is expected to be a negative number. So we get negative 4, negative number, and that makes sense. Any questions here? So now let's look at example 5. So example 6. Now, example 6, yeah, I like this from right here. Example 6. Let there be a tank. Let there be a tank in the shape of an inverted cone, bottom vertex and top circle. So now, you know what? I don't know which one is a cone and which was an inverted cone. This is something which I can never figure out. On the test, I'm going to make this very specific. Bottom vertex, top is a circle. And so what we have is we have a cone like this. Let me do this again. Like this. Again, I'm not sure whether this is called an inverted cone or regular cone, but